Recently, Casey Mann, Jennifer McLeod, and David Von Deroe of the University of Washington Bothell nearby discovered a new polygonal tiling of the plane using irregular polygons of what shape? Were they all quadrilaterals? Easy for you to say. Pentagons, hexagons, or heptagons? So you all answered pretty quickly. Let's see how you did. 3 people. It was pentagons, that's right. Who got that? All right. So Ankan, how'd you get that?
Actually, in this local math contest I took, there had a question about this thing. So yeah.
Really? So that was recently, or?
Yep.
And then you told that person to send the question to us to use in the national game?
Obviously.
Obviously. All right, so that worked out well for you. How about the other two? Had you heard about this that way or in the paper? Or?
No, I just guessed.
You guessed, all right. And who else?
I saw it in an article.
You saw it in an article, all right. So however you got it, it was good that you knew it was pentagons. And then I think it's the one in the lower right here that is the new tiling. And the other ones have been discovered. There was some question about whether there was another one, and then that team discovered the one in the lower right. So a nice way of finding out. Ankan, very good. And so here comes question 4 for 400 points. In the complex plane, what is the smallest distance between roots of the equation z to the 5th equals 1? Is that distance the square root of 5 minus square root of 5 over 2, b, square root of 5 plus the square root of 5 over 2, c, square root of 5 plus the square root of 5 over 8, or d, square root of 5 minus the square root of 5 over 8? All right, so that was, you did break the pentagon real quickly. I was surprised so many people knew about that. This one probably definitely takes a little more calculation. And let's see what the correct answer is. Oh, who want to be a mathematician flag? It did turn out to be a, the square root of 5 minus the square root of 5 over 2. Who got that?
I guess.
You guessed that. So it's not particularly easy. You might have to know something about quintics. Maybe that could help. You can try to sketch them on the circle, but the cosine's not one of the ones you're used to. 2 pi over 5 or whatever you happen to be working with. But you can do a couple algebraic tricks with with factoring the 5th to try to boil it down to a quadratic, and then you can get this root, or then you get this answer, we hope, and figure out whichever distance you happen to pick. You might pick the one on the left, which has that nice, it doubles the sine property, or the first one between the real root and then the one that cosine of 2 pi over 5. But those are the roots. Of course, you don't necessarily know those offhand, but that would be a way of getting it. Or sometimes people happen to know that cosine because it does turn out, well, it's not nice, but it's one that comes up sometimes. But anyway, so we'll see what the score. Oh, now we'll see the score, and same like we did in the first semifinal. We'll see the score at every question after this. So Abishek got all the first four right for 1,000 points. Allison also has 600 points, so they're tied for second. And Samir at 300 points, and Casey at 100 points. And then Samir, so I mentioned you're from Liberal Arts and Science Academy. And then last year when we did it in San Antonio, there was a contestant from LASA, and we've had one previously as well. But a lot of the people came to the joint meetings that time from Austin, which in Texas is like, just going down the street. But now they entertained the notion of coming this year, right?
Yes, yeah. They did. We didn't have enough people going this time, but my teacher is really enthusiastic.